Good afternoon, everybody. Thank you for joining this CIBSE webinar. My name is Anastasia Milona, and I'm the Research Manager here at CIBSE. I will give an overview of the weather data, and then my co-presenters, Dane Verk from Atkins, will give a little bit more of the technical detail of the weather files, their production and use, and then Susie Diamond from Inkling will give us the user perspective with some examples as well. You can put all your questions throughout the sessions in the questions application of the webinar software, but we will address them at the end. So I will start with my presentation. As I said, I will give you an introduction of the weather data sets and their use, why we decided to revise them, and I'll give you a summary of this revision. So weather data sets are used in dynamic thermal simulation of buildings to describe external conditions and allow the performance analysis of internal conditions. They are hourly weather variables measured over a year. We got those from the Met Office. And the weather variables include air temperature, humidity, solar radiation, and wind. The weather data sets come in various formats depending on which software you're using. And we have some examples of the software and the format that they are available for. So we have two data sets, two types of data sets. One is a test reference year. That is a typical year that is used for energy assessment of buildings. They are consisting of average months over a 20-year period, and the baseline this period is 1984 to 2004. So the next one is the design summer year. This is again over a year, but is used for to evaluate overheating risk in buildings. The previous version of the design summer year was the third hottest year based on a 20-year period and measured as the mean temperature for the period April to September. So, so the revision is based on an updated baseline. So the new baseline of both the test reference years and the design summer years is 1984 to 2013. We did this to capture any observed changes in climate, and the test reference years were produced in the same way, so average months taken from this baseline were put together to produce this average year. But the design summer years are now following a new methodology that is very much explained in the TM49 design summer years for London. This was available a couple of years ago, and we use the same methodology to do the same for all the other UK locations. There are two technical papers if you want to learn more about the new test reference years and design summer years and their methodologies. Those are published in the Building Services Engineering Research and Technology Journal that is freely accessed by all CIBSE members. Sorry. Just a little bit to give you a little bit more information on the design summer years. They are based on a new metric that describes the interaction between internal and external temperatures for a conceptual building. And we have 3 design summer years just to give a better representation of their relative severity and expected frequency. So on top of the current weather files, we have the future test reference years and design summer years. Those have been updated based on the UK climate projections 09, that they are probabilistic in nature. And I have listed the time periods and emissions and percentiles that those are available for. You can see that we have 3 timelines: 2020s, 2050s, 2080s. For the 2080s period, we decided to just release the high emission scenario, just because there isn't much difference between emission scenarios that early on in the century, and then as you go to 2050s, you have medium and high, and for the 2080s, that the uncertainty is higher, we have all 3 emission scenarios. For those of you that haven't used the files and you're not very familiar with the concepts, there are a couple of really useful CIBSE publications. One is TM55, that is 5 case studies that they used these future weather files to assess building performance. And we also created those probabilistic climate profiles, again a CIBSE publication. Both of the publications are freely available for members and non-members. The pro clips give you a visual representation of all the scenarios for certain weather variables. So I would very much recommend you look at those if you want to familiarize yourselves with, especially with the future weather files. My final slide, it just summarizes all the resources that they are available to help you understand what it's available and how you can choose the files that you need. On the top, you have the address where you can access the weather files, and you can find the process of actually ordering them. We have a document that it's the frequently asked questions that you can have a look, and we have a couple of case studies using test reference years and design, the new test reference years and design summer years, and we have a technical briefing that describes and summarizes the methodologies and those case studies. I'll pass you on to Dane, because he's actually going to talk more about the technical detail of the methodologies and the case studies. So on to you, Dane. Thank you.
Thanks, Anastasia. Right. Thanks, Anastasia. Good afternoon, everybody. I'm going to go into a bit more detail about some of the things that Anastasia went into, give a sort of technical overview. So a bit about myself. My name is Dane Verk. I was doing an engineering doctorate with CIBSE, and during that I was actually involved in the team that updated and released the weather files. And now at Atkins as a graduate building services engineer, which I started last September. Right. So just an outline of what I'm going to go through today. I'm going to talk about the reason for the update, some of the reasons, go into the detail about what was updated in terms of test reference years and design time years, and then also go into a bit more detail about the design summary update, and then go look at a case study just to show the differences between the old and the new files.
Hi, sorry, Dane. Sorry for interrupting. We can't see your slides yet.
Okay.
If you can, we can see your.
Can you see them now?
Yes. Yes, that's fine.
Yes. Sorry about that. Okay. Well, I'll just I won't start again because it's just an introductory slide. I was just saying that, just outlining what I was going to go through. Right, that's better. Okay, so the original files were released in 2006, and as Anastasia said, they were created from a baseline of 20 years, 1984 to 2004. By updating this baseline to a 30-year baseline, we'll incorporate any effects of the warming climate in both the test references and design sum years. And this.
Sorry, Dane, again for interrupting. Can you maximize your view option so that it goes full screen? If you can, then fine. Don't worry. That's fine. That's fine. Don't worry.
Is that
Sorry.
fine?
Go on. Yeah, it's fine.
Okay.
Sorry.
Okay, yeah, we'll go back. So what were the issues with the previous design some years? Well, the methodology, there were issues with the previous methodology for selecting it, and it could be argued that it didn't select years with summers that had overheating events. So then when you come to overheating assessment, you're not really using sort of data that you would want to be using. And there were other evidence of inconsistencies between the test reference year weather files producing more overheating than design some years for certain locations, which completely defeats the object of having designed, two different sets of files for different types of analysis. The other thing is that the previous data set for the future weather files used different climate projections. So in 2006, they were using UK CIBSE 2 climate projections for morphing the weather data, but since then that was superseded by UK CP09 climate projections. So this also needed to be taken into consideration during the update. So a bit about the test reference here, or weather files, and their update. So I know there's going to be a mixture of sort of backgrounds within the webinar. So the test reference years they represent typical years that are used to determine average energy use within the buildings. So the same methodology was used to select these years. The methodology included selecting representative months from your observational data set using using parameters such as air temperature, relative humidity, and cloud cover, with wind speed as a secondary parameter. So these primary variables of air temperature, relative humidity, and cloud cover, they're used to find the 3 months with the lowest ranking. And then from these months, the months with the most average wind speed is chosen as the representative months of that location. The baseline for selecting these months. And then when we've updated the baseline, the number of years that you can select average months has changed. So I mean, this is an example for London and Manchester I've shown here. For London, January, you have 2011 instead of 1988, and for Manchester, 2007 instead of 1987. So that you can see that using the updated baseline does change your average months within that year. So the design some year was a bit more involved, and there was a bit more of a significant update because the whole methodology changed. So the previous methodology, as Anastasia went through, involved calculating the mean temperature over the period April to September for each year in your observational data set. So previously it was 20 years and now it's 30 years. So the design some year was chosen as the third hottest year. So in TM49, probabilistic design some years were produced for London, and these were produced to replace the current design sim years with a set of years that better describe overheating events in terms of relative severity and expected frequency. I mean, we all know a summer is not going to be hot the whole time, and overheating is going to be impacted by these sort of spikes in temperature, or where you have a heat wave event. And the old years weren't really representing that, and so this is what TM49 was trying to, what the new methodology is trying to do, is select these events. So the new files are selected using new metrics based on how far the external temperatures depart from the internal comfort temperatures of a conceptual building. So this conceptual building, which you can read more into in TM49 and also the Berserk papers, essentially it's the external temperatures are a proxy for the internal temperatures. So when you see changes in the external temperatures, such as heat events, heat waves, then it's going to impact the amount of overheating within that building. So to choose the candidate years for design some years, the metrics are used to rank historical observed years in terms of their return period of hot events, the duration of these events, and intensity of these events. Now, this is quite important because now instead of having one design summer year, we have 3 design summer years for all locations. And to understand what each of these files represents will actually enable designers and practitioners to use these to the best to assess overheating risks within their buildings. So events are defined as warm spells. So it's a continuous period where at least 1 hour of each day goes above a threshold temperature. The intensity is the total of the metric that you're ranking your historical years divided by the number of days of the event, which is essentially the duration of the heat event. And the return period of the hot event refers to the frequency of the event with an associated exceedance value. So as with the London design sum years, there were three per location. And so the design sum years, if we think about it, as I said in the previous slide, the events are hot events, the intensity, and the return periods, then you can define these three design sum years, and that's how they were selected. So a design summer year 1 is a moderately warm summer. So any given summer, future summer has a 1 in 7 chance of being equal or hotter than the selected design summer year. So it's interestingly for London Heathrow design summer year was 1989, and actually it's the same year. Design summer year 2 is a short. It represents a summer with a short, intense warm spell. So this represents an intense extreme year. Then has a heat event the same length as design summer year 1, but with a higher intensity. So you could have a weekend within that summer that has a very hot event. And design summer year 3 is a long, less intense warm spell. So the long extreme year has a less intense extreme than the high intensity year, but a more intense extreme than the moderate summer year, but also a longer duration heat event than the moderate summer year. So essentially you've got a warmer heat events than your design summer year 1, but they're less intense than your design summer year 2. And that's actually quite interesting because you've got two design summer years where you have different types of heat events. So how is your building, depending on the type of development and the location, going to be impacted by that? By a long spell of hot weather or by a short spell of very intense weather? Okay, so just going to briefly go into some of the case studies that were released during the update. Just some brief details of what the case studies represented. We looked into an existing naturally vented semi-detached dwelling and an office, and we looked at two scenarios for each: an uninsulated, poorly designed base case building and an insulated base case which meets regulations. And we actually looked at, because we wanted to keep it as simple as possible, we chose the old stationary overheating criteria. You'll understand why we decided to use these as indicative examples of how certain buildings will respond to changes in the new files. So the reason we kept it that simple is because when you have a graph like this, where you have your results for the uninsulated scenario, you have this is for the dwelling, and it's the bedroom zone, and you can see that for every single location, the new design summer years are warmer than the old design summer years, and it's the same for when you look at the office. The same scenario. It shows that the new design summer years are definitely a lot warmer than the old ones, and this is going to impact overheating assessment across all locations. Okay, so just a bit on the future weather files, because now that you've got 3 design summer years and test reference years, and then you have all these emission scenarios, there's a lot of data there, and some of the questions we get at CIBSE, differences between CIBSE weather files and Prometheus weather files, and Susie's actually going to go into more about how sort of tools you can use to select what the most appropriate future weather file is. So the future files are produced from the observed data set using a morphing methodology. So essentially, this morphing methodology shifts and stretches the current observed data from the original baseline using UK CP09 climate projections. So when you've got a baseline design summary or a test reference year, and then you choose a CIBSE future weather file, you can directly compare them because it's shifting and stretching the same baseline data. Now, the Prometheus weather files are produced using the weather generator, and this uses the rainfall from a 1961 to 1999 period for baseline for calibration, and then these are morphed using the UK CIBSE 9 projections to produce future weather files. The other difference between Prometheus weather files produced by the weather generator is that the solar model is different. So the solar model that is used to create the solar radiation values is different to those that CIBSE uses to create design summer years. So the current CIBSE weather files, so if you have a current CIBSE file for Leeds or something, and you want to use a Prometheus file to compare with the future, then you can't actually directly compare them. Okay. So if you want further information, everything that I've covered goes into more depth, and also in the technical briefing, and also it has references to all the sort of literature and Berserk papers that will if you want to look more into sort of the methodology, the sort of reasoning, thinking behind or how these were updated, and also if you wanted to look at the differences between the old test references and current test references, there's some more information on that. Okay, so I'm just going to hand over to Susie now. Thanks for listening, and do type in any questions into the chat. Thank you.
Hello, everyone. I am third up. Yeah, this is my presentation. Just to welcome so many people onto the webinar this afternoon. It's very exciting to know that so many people are out there listening to us. I've been asked to talk about these weather files from the end user perspective, from the practitioner actually trying to make use of them as a building physics engineer. So I'm part of Inkling. We're a small building physics consultancy. A little bit of information about us before we plough on. Okay. So I'm going to repeat a little bit of what you've already heard. I think it bears repeating because it is quite muddling. So I'm just going to give you my take on how to sort of sort it out in my head and understand the multitude of weather files that we now have at our disposal. So as we had in 2005 CIBSE weather set, there are the same 14 locations spread across the country, and there's the same TRY and DSY split in terms of test reference years for winter and heating analysis and average years, and then design summer years, which are used for overheating and looking at hot summers and testing cooling and overheating risk. For each one of those 14 locations, we've got current TRY weather file, which is, as Dane has explained, the baseline set, so where we are now, and then the three different DSY files that, again, Dane's just explained in terms of having a moderately warm summer year, the DSY 1, and then DSY 2 representing a short, intense warm spell, and DSY 3, which represents a longer but less intense warm spell, so a sort of longer heat wave. And those three DSYs replace the one that we used to have for each location. So we now have to just get used to having those three options available and understanding the differences. The whole different set is the future files, which again Dane's just talked about, which are the morphed set, where all of those files just mentioned are pushed into the future using the CP09, UK CIP09 projections. And we'll cover those next, because in terms of the future files, for each location, for each of the DSY files, we push ourselves into the 2020s, 2050s, and the 2080s in terms of the projections. And then within each of those timescales, there are low emission scenarios, medium emission scenarios, high emission scenarios, and within those, there's the 10th, 50th, and 90th percentile files, and those are included for each of the DSY files. So one point to make is that for the 2020s, we've only got the high emission scenarios, and for the 2050s, we've only got the high and medium, but we're still looking at an enormous number of weather files, so just to brace yourselves for that. But we do have some help figuring our way through them. I will come on to that in a second, but the ProClip charts are really valuable, and there is a slide on that just coming up. I thought it'd be quite helpful to talk about the way that those files are delivered. So if you buy the package from CIBSE, you get a big zip file, loads of files in it. And when I first saw them, it took me a little while just to navigate my way around and understand what was what within them. So the first thing to note is that there is a helpful naming convention. And if you bear that in mind, it really does help. So the first couple of letters of the file name, and that includes the folders that they're kept in, is either WC for weather current or WM for weather morphed. So if you're looking for Fs for future, give that up and look for WMs. The next letter in the sequence will be, oh, hang on, WD, we've got 16 for the 2016 release. And then, oh no, hang on, before we get to the 16, we've got either D for DSY or T for TRY file. So hopefully that's fairly clear. And then we've got a 3-letter shortening of the location. So I've put an example there on the screen, and you can see from one halfway down, WCT 16 LON, which is weather current, TRYs for 2016 release for London. And I'll come on to the fact that London also has 3 different locations in a sec, because I think that also bears going into. So this is talking about which to use. And I know Anastasia mentioned the ProClip document. This is really where it comes into its own. And if you've not looked at it, I really recommend you download it from the CIBSE website. The valuable bit is in the charts at the back. And there's an example coming up on the next screen, although you can see a glimpse of it there on the title page of the document. It includes all 14 locations, and what it does is show you how all the different files compare to each other for different key variables. So there are charts for seasonal mean air temperature for the 4 different seasons, the daily minimum temperatures for winter, the daily peak temperatures for summer, and the seasonal daily precipitation for the 4 different seasons. And moving on to the next slide, when we're looking at overheating risk and we're looking at DSY files, the way to sort of interpret between them is to look at the summer mean daily maximum temperatures. So if you can find those charts within the ProClip appendix at the bottom, for each location, you have to keep scrolling through. I've put an example here for Cardiff, and the different colour bars show you the low, medium and high emissions comparison for the different year bands, and then show you the percentile variations. And I still get confused, but the point, and I've highlighted that with the purple squares. I think I can probably get a little fuzzy thing to show you, is being able to see the step change between those files. So in consultation with your client, you might want to talk about what level of risk you want to assess your building against using a model, and we would usually recommend the 2020's high emission 50 percentile as a starting point here, and then you might, depending on the intended lifespan of the building, you might want to take a medium or high emissions. Usually we go for 50 percentile because once you start looking at 90th, it's really quite severe. But you can then, it gives you the perspective to enable you to choose which are the right files to follow. There is no right or wrong answer specifically here. There is some guidance out there, but it's up to you in consultation with your client to talk about what level you want to look at. And if you're looking at more vulnerable residents, for instance, you might want to take a more conservative, higher risk approach and run against the tougher files. So do explore the ProClips. It takes a bit of time and reading through, but I think they're really valuable in this context. So definitely one to look out for. I'll get my phone here and do it next. I won't go next. I think I might have to take this bit off. Sorry. There we go. Okay, so the next topic I wanted to cover from a practitioner point of view is compliance. So one of the questions that comes up a lot is whether these new files are legitimate to use in Part L compliance, Part L2A specifically. And the answer is that CIBSE are currently in discussion with DCRG about this, and they've not yet had official endorsement for using this new weather sets, TRY files. So until that happens, and we don't know when that will be, we need to continue using the 2006 TRY files that we've been using for the last several years. When it comes to overheating risk assessments, it is increasingly recommended that we are using the 2020's DSY1 files, most appropriate for the location. It is 2017 after all. 2020 really isn't that far away, and to be using the 1989 files does feel quite retro now. So it is, I believe, going to be recommended in the new BB 101 that the 2020 DSY files are the compliance benchmark. I believe that's also going to be the case in the new forthcoming CIBSE domestic overheating TM. Watch this space, it's coming soon. And within TM52, it recommends an appropriate DSY weather file. So there is some judgment to be exercised there, but my recommendation would be to look at the 2020 files again. It just seems to make sense. The DSY 2 and 3 files are, as mentioned by Dane, they're really, they may not be required to pass overheating criteria against, but they provide a really valuable way of exploring the impact of a more severe heat wave on your building. So looking at those in tandem with the 2050 and 2080 future projections, it's quite helpful, perhaps not to run too many iterations or you'll bamboozle everybody, but to pick out some scenarios to test in consultation with your client to explore the future proofing and at what point further mitigation options might be necessary. This is in the context of overheating risk. So hopefully those are some helpful tips. I'm sure more things will come up in the future, but perhaps we can talk about them in the questions if you have more questions. So just to finish up, I've got a few little tips and tricks that I've picked up in terms of using the files with TAS and with IES. My business partner has kindly supplied some tips on that score. So TAS, when we're running TRY and DSY files in the compliance sections, it will only understand those files to be TRYs and DSYs if they are labelled space TRY or space DSY. And some of the files, as you receive them from CIBSE, aren't necessarily named exactly like that. I think some have underscores in. So you may find that it fails a run check within TAS when you're running a TM52 or a Part L calculation, and you just need to go into the TBD, rename the weather files with a space TRY or space DSY, and you'll find that it runs more smoothly. So that's one little tip. The other is that, again, within TAS, you can drag and drop weather files within the databases. So if you want to collate a useful set together that are the ones that you use on a regular basis, you probably already know this, but that's quite a sensible thing to do when there are so many weather files out there. But just don't forget that you have all this wealth of data and focus in on only one or two files, because you'll miss out basically on the variety that there is there to make use of. Within IES, again, there are some issues with naming files, and you may find that they come up when you're trying to select them within the software, and the file names aren't the most helpful. So you may want to rename them in your database to make it easier to select the right one within the software when you come to do so. And again, I think that's as we go forward and we use these files, we might be able to find a place maybe on LinkedIn that we can share tips and tricks as we come up, or questions that come around. But if anything comes up for you today that you already have questions, I think we're about to segue into the section on questions. So that's my bit. Anastasia, are we handing back over to you now? Hello.
Hi, yes. So I will go through all the questions that we have received so far. I believe we have answered most of them, but I will go through them anyway. So we have a question about the use of the data in the calculation of DEX. I think Susie has covered this already. The old test reference years are still used for compliance and DEX and EPCs and all that. As soon as the DCLG accepts the new weather files, then these are going to be the new compliance files. We have a question about the difference between the future CIBSE future data and the UK CP09 weather generator. I think Dane has covered that. I don't know if Dane, you want to say a little bit more on that? You talked about the Prometheus data, but do you want to mention a little bit about one versus the other?
Yes, so I did cover this in the slide, but I'll just go through it again. So with the way the morphing methodology works is that it uses your design time year 1 or your test reference year, and then it uses a morphing methodology to produce the future files depending on your emission scenario. So if you've got depending on the baseline data, that's going to impact what your future file is. Now, if you're using a current CIBSE file and then you want to use a future Prometheus file, you're not actually using the same baseline data, so you can't directly compare your current to your future scenario. There's the Prometheus website has a README file which has a troubleshooting section in it, which goes through the differences, briefly touches on the differences between the methodologies. The other thing I mentioned in my slide is the solar model to produce the solar radiation between the weather generator and the CIBSE valves is different. And especially for overheating, if your solar radiation is different, it might not be that, but then, comparing them, you can't directly compare them. So I hope that answers that.
Okay, thank you, Dane. The next one is about, it says, we bought in the past some of these files via CIBSE, would we need to buy them again? So these are now the new files. There is a period where if you bought them a few months before the new release, you might get a discount. I suggest you email the address that we have now, you have now on your screen with this question and some details about when you bought the previous data in case you can get a discount. Are the high, medium, low emission scenario associated to the city where the building is located? They're not city specific, they are climate specific and national and global specific. So the high and medium and low emissions has to do with how the carbon emissions, the greenhouse emissions will improve or not globally, and what's going to be the impact of these emissions in the global climate. And this is now scaled down to 25-kilometer grid. So when I analyze the climate change adaptation of specific building in the future years, do I have to predict the emissions that will be expected in that particular city and then choose the more accurate emission scenario? You don't have to predict anything. The emissions are already given, and you just choose the city you want to do the analysis, and you do your analysis. I hope this covers your question. So there are a couple of questions on the design summaries and how you select them. I think Susie tried to give you some indication as a practitioner of how she decided on the use of design summer years. I would say that we have the 3 design summer years to give you a better tools to assess different types of hot events for your building solutions. Yes,
could I say something on that? No.
Yes, of course. Yes, I was going to ask you and Susie to comment on that.
Yeah. With overheating risk, you're assessing risk, within the building. So if you, other CIBSE work that I've been involved with has recommended that even though you only have to use one for compliance, it's worth looking into the other files to assess the potential overheating risks. That's the advantage of having all of these 3 files. Otherwise you're meeting compliance, and then say hypothetically there is a summer in the future where you do get an obscure heat event, then you haven't actually factored that into your design. Yeah, that's what I wanted to say. But Susie, have you got anything to say on that?
Not especially. I think the only thing I'd advise caution in is that if you start iterating the model against too many weather files, you'll just end up confused. So it's important to have a think about what scenarios are of particular concern to you and your client for this building, and test those rather than run 10 different weather files and then not really know what that's telling you in terms of what you should be changing, because I think it's just, yeah, you can end up with too much data to begin with. That's just my experience. I think you need a clear strategy for what it is you're trying to understand. and then look to the weather files to resolve that.
May I also add that the ProClip
Does that help?
publication, yes, Susie, thank you. The ProClip publication has 4 different case studies that try to provide a framework for selecting the right weather files based on your building, your vulnerabilities, people description, etc. So it might be worth looking at that as guidance on your selection of weather files. I'll go to the next question. Is the use of the new design summer years compulsory? That is, are the old design summer years definitely obsolete? I would say yes, because they're superseded now by the new design summer years, and all the new standards are going to suggest the use of the new design summer years, like the BB 101 and the GLA requirement for the long-term plan as well. Monthly, we covered that. Sorry. In relation to conducting an overheating assessment, does this mean all 3 new design summer year files should be incorporated, or is there a recommended weather file? Also, would overheating assessment criterion guides need to be revised to incorporate this? I think we covered the 3 design summer years versus 1. There are 3 design summer years. Ideally, you will use all of them to assess how your building reacts to different types of hot events. And there is the TM52 that provides a new overheating assessment criteria. And we are also about to release a new overheating assessment process for homes as well that will clarify exactly which designs are here and which criterion to do your analysis against. So this is work in progress. I understand from your questions that most of them, you need clarification of which file you need to use. The simple answer is you need to understand the vulnerabilities of your building and then do some checks with the different hot events, even if you're just looking at the hot periods for each of the design summer year, to look how your building will respond to different types of hot events, because unfortunately there isn't one day or 2 days. There is different types of hot events, and these 3 design summer years will give you that that tool that you can use. So test reference years for part L, we covered that. Is it already mandatory to use the new 2016 rather 2006 weather files for design calculations, that is building energy consumption and thermal comfort studies? I would say yes, unless you're doing a part L compliance, in which case you still need to use the old test reference year. What is the future test reference year used for? That's for assessing your energy demand over the future decades. So the way you use it for now, for current energy use of your building, you use them based on future projections to look at how your building energy profile will change based on these new temperatures. Guys, Susie and Dana, I'm answering the questions, but if you have anything to add, please interrupt me and answer them as well. As the future weather files are basically best guesses, why not just use the updated design summer year results with potential swings around the peak results? I'm not sure I understand this question. Dane?
Sorry, could you just read that out again? I think
as the future weather files are basically best guesses, why not just use the updated design summer year results with potential swings around the peak results?
Well, I mean, it's not.
That's what they are, aren't they? The future weather files. That's exactly what they are.
If you're changing your just the peak of results, then the rest of your summer doesn't change. So, I mean, with the emission scenarios, what you'll do is you're morphing the whole summer, or the whole weather file. So that's going to affect your the whole summer period. So you might design something, you might design a development that is passes overheating assessment apart from that one heat event for a current file. But then in the future, in 2050s, it actually fails for a lot more longer lengths during the summer, and that's going to have impact on your future design conditions. So I think that's what the future weather files are doing. I mean, if you want to test the actual peaks, just to look at the most extreme conditions, then yes, that would work. But yeah, I hope that answers that question.
Okay, so the next question, the new design summer year weather files appear extremely hotter than the old files. How do you think this will impact the use of natural cooling for buildings? Will it still even be possible? Can I ask Susie to give an answer to this, just because she has used the new design summer years and she can give us a little bit more of her experience. Susie?
Yeah, no, it's a good question. And the thing I point towards is that we're moving more towards the adaptive thermal comfort methods for predicting overheating risk in buildings, so TM52. And that, because that looks at the weather file and takes a running mean from the weather file used, rather than setting a fixed temperature threshold that needs to be met. It means that with hotter weather years, it's not necessarily making it impossible to achieve a pass. And so what comes with that is that if our climate does warm up and we do get significantly warmer in parts of Britain, then we as humans will adapt. Plenty of humans living in hotter parts of the world than we are, and get used to it, is the theory, and therefore our requirement for cooling may not increase as much as when we look at those weather files now and go, blimey, that's hot, we're going to need cooling. We might find that when we get to that stage, we have adapted, and that with appropriate shading and breezes coming through the open windows and so forth, the requirement isn't quite as severe as we might imagine at this point. So, so that's the context. Does that help?
Yes. Okay, great. Thank you. So the next one is for the BB101. I think, Susie, you have covered that the new BB101 is actually suggesting the design summer year 2020's high emission scenario 50th percentile.
That's right, yes.
The next one is again on the design summer years and choosing them. I think we have covered that. There is one for you, Susie. Susie, you mentioned guidance of selecting the new files is out. Can you please indicate where or what we should be looking into?
In terms of selecting the file, so are we talking about the ProClip publication that I went through?
It doesn't specify. It doesn't specify. I would.
If you search for ProClip on the CIBSE knowledge portal, then it should come up. I can't remember what the full length of that document is, but I think it's on my slide, so we can probably get that for you.
Hi,
Can I mention one thing, Anastasia?
Yeah.
Sorry, I missed a slide on TM49, which is the London weather data that came out a year or two ago. And I just wanted to cover that because I mentioned it before, that we've got 3 locations for London.
Okay.
I don't know if that slide can be brought up. But it's relevant to know that if you're doing a lot of projects in London, and many of us are, that there are 3 different locations. And there's London Heathrow, London Gatwick, and then London Weather Centre. And they represent 3 different levels of urban heat islands. So London Weather Centre is right in the middle of London and represents all the sort of very central London, very ultra-urban projects. And then London, I'm not going to get this the right way around, London Heathrow is a more suburban location, so that might be inside the M25, but perhaps not inside the North Circular, South Circular ring. And the London Gatwick files are then a bit more rural, So that's perhaps just outside the M25. So that allows you to have much more specific file choice for those London projects where urban heat island is a significant factor.
Okay, so there's another question for you, Susie, from Nicola Connor. Hi, Susie. Does the GLA now require the use of Design Summer Year 1 with a possibility of 2 and 3?
The GLA, well, that depends on the what sort of project. To be honest, I'm not sure. I think we're going to be recommending that for domestic overheating risk assessments that DSY1s are used. For the analysis for the pass-fail criteria. I imagine the GLA will require any other types of building to be done in accordance with suitable, usually CIBSE guidance. So where we've mentioned that there is guidance specifically there, then yes. And I think gradually everywhere is going to be moving, particularly for overheating risk, to the new DSY1s.
Okay, yeah, I think Nicola is actually asking for the domestic, but yes, we are discussing with DLA the adoption of the new CIBSE overheating methodology for domestic, and we are indeed suggesting one design summer year to be used for standard practice. The next question is which percentile weather file is recommended to be used? Again, we are not suggesting one percentile. We have produced 3 different percentiles. Again, the ProClips is a very good guidance if you want to look at the variability between the percentiles, and that I think will give you a better understanding of what's the difference between the 10th, the 50th, and the 90th. Given that the new design summer years seem to present more overheating risk in our models than the old design summer years and encouraging the use of future weather files, are we encouraging over-specification, over-design, and otherwise undesirable design decisions? There is less insulation, more unnecessary comfort cooling. Susie, one for you maybe?
I think that's very similar to the question we covered before about the weather files getting hotter. And yes, there's a risk of that, but we are in a heating climate. I do think that use of the adaptive thermal comfort criteria is sensible, and that hopefully will not make for a mad dash towards comfort cooling. But as comfort cooling becomes, the COPs are going higher and higher, and the carbon intensity of the grid gets lower and lower, comfort cooling is perhaps less of a demon than we once thought it was. And that used in moderation, it might become quite a sensible thing. So that's one to think about.
Okay, what type of file would design builder require?
EPW.
EPW, yeah. Which current design summer year is recommended for cooling loads plant sizing? So the design summer years are used for overheating analysis. For sizing, you need to use the weather data in Guide A. Is there clear guidelines on which weather file to use, or is this based upon a level of interpretation by the consultant-client agreement? Wherever there is a clear indication in a standard, then you follow that specification, either the GLA or the BB101 or the BISRIA, the BREEAM or whatever else. If not, then it will be interpretation based on your experience, engineering experience, and discussion with your client. Do you know when the new BB101 is due to be released? Oh, I thought that was already out. Susie, do you know when it's going to be out? Hello, Susie?
Sorry, I forgot to unmute myself.
Oh,
I believe the BB101 final draft has been completed, so I think it's just a question of getting it published now. We have been waiting for it for several years, so I wouldn't recommend anyone hold their breath, but I do believe it's imminent. So hopefully in the next few months we'll see that published.
Great, thank you for that. If I have collected weather data using a local weather station, how do you think I can use them? I think this is a good question for the Met Office. And which software do you use for creating weather files? We didn't use a software. It was based on a statistical analysis that was done in Exeter University. Well, I don't think. Dane, do you know if we use the specific software for creating the weather files?
So I mean, this is all based on observational data.
Yes, that's right.
So CIBSE licensed the data off the Met Office, and if you're using something like the BADC, which is the sort of it's where you get a lot of weather variables from, which the Met Office database. Then that is, I mean, it even says on there that it's only for research purposes. So you'd have to. I think I'm not sure what the licensing is with the Met Office for individual observational data sets, but yeah, so it's all based on observational data sets, and then you use the different methodologies to produce to create the files. Yeah.
Okay, great. The next one is about BREEAM. The design summer year weather file should be used for the 50th percentile for the projected climate change scenario. This refers to the 2020s design summer year 1. Does any of you, Dane or Susie, know what the requirement, the BREEAM requirement is for the design, which design summer year to be used?
I don't actually.
Sorry, I'm not familiar with that. We'd have to look that up.
I don't, I'm sorry. Yeah, that's a question for the BRE, yeah. Anastasia, I didn't really catch on those file replacement. What is the purpose of doing this? I'm not sure I understand this question. So if it's based on the revision, it's to add a 10-year period of observed climate in our baseline that better represents how the climate is changing. So that's why we did the revision of both the design summer years and the test reference years. What about values of tables in the future? Will keep constant. I don't think I understand this question, I'm sorry. How do the CIBSE files compare to weather shift? Does Dane or Susie, you know what weather shift is? I'm sorry, I don't.
I've never actually heard of weather shift. I know that people use data from Meteonorm and other, yeah, but I've never heard of weather shift. Sorry.
Why not?
Neither, sorry.
Okay, sorry, Susie. Why not compile a design summer year 4 with an event similar to 2003 heatwave in trends?
Sorry. I just jumped in. Sorry. If you finish
go on.
Okay.
Yeah, go on.
Okay.
Yeah, it's finished.
Well, that's the thing. So whoever answered that question knows that 2003 was a very specific type of heat wave, and it was one of the warmest years on record. The top temperature was around 36 degrees, which is not common for for anywhere in the UK. So actually, design summer year 2 for London is 2003. So the methodology is working because it's selecting these types of heat events. So yeah, whoever asked that question, I'm yeah.
Argyeris Oreopoulos. I know Argyeris. So we have hundreds and hundreds of questions, but we're running out of time. All the questions that we haven't answered, if you could email them to the address that is on your screen, then we can slowly go through them and provide an answer for you. I'm really sorry. We didn't expect that many questions. Hopefully we covered most of them, but if you feel that you really still need answers to your specific questions, please use this email address to email us, and then we will between the three of us, we will try to answer them as soon as possible. Thank you very much. All the slides and the webinar, the audio, will be available online. You will receive an email with a link tomorrow, so you can hear the webinar again and the Q&A session. I hope you found it helpful. If we see that more questions come in, we might organize a follow-up, perhaps when we have more case studies that we can showcase the weather files. I will just say goodbye, and thank you very much to people that helped me organize it, and to, of course, Dane and Susie for their time presenting. Thank you very much.
Thank you. Thanks, everybody.